Hi, are we standing? This is the
the vibe. Yeah, let's go for it.
All right, we have the most unique people to do a battle because we respect each other a lot and pretty generally non-combative people.
That's right.
But we're trying something new.
Yeah.
It's all about learning. So I think you're wrong. Let's start with that.
Okay. Let's go.
Yeah. So the topic is effectively verifiable computation. For those who are not familiar with the topic, effectively, how do we actually ensure that the computation we do for AI, for kind of general, data processing, machine learning, and everything in between, like medical, etc., is done exactly as you expect and not, be modified in the middle. And there are a few different approaches to do that. Mm-hmm. And so I'll let you introduce your approach, and then I'll tell you why we're wrong.
Yeah. Okay, we'll start with what we agree on, and then we'll go fight. So if you think about what are blockchains, I think of blockchains as unstoppable, verifiable computers. Right? Unstoppable. You run like a blockchain like Bitcoin, nobody can stop it. As long as there is enough incentive, somebody will keep it running. Verifiable, it does what it says it does, right? So it runs the same code. That's why there's only 21 million Bitcoin. That's why you have your own coins. So blockchains are unstoppable, verifiable computers. That's what they are. And I think there's something really exciting and interesting at the intersection of AI, AGI, and unstoppable, verifiable computers. Put them together, you get unstoppable AGI, something quite interesting and exciting. Verifiable AGI, more tame, but still pretty useful. But I think that I think we agree on, right? So we are excited that there is this prospect that these two things are coming together. This is a very technological view. I can also take a product view and say, from crypto, the biggest thing that we have is an apps problem, right? So we build a lot of infra. Illia and Near have built more than their fair share of it. And every time I hear a problem, Illia is like, nah, Near already has it solved, so don't worry about it. And it's true. But we build our fair share of infrastructure, and the main thing we're lacking is apps from crypto. On the other side, with the coming emergence of Cambrian explosion of intelligence, we're going to have a big trust problem. How do you trust these intelligences to do what they said they are going to do? And so obviously there's a very strong fit there. Crypto is the trust platform, AI is the new app platform. They intersect, solving each other's problems. Again, we are in agreement on that. Okay, so having stated all the obvious things we agree on, now let's go to how do you build unstoppable, verifiable agents, right? So it's something that we're interested in. I think when you look at existing blockchains like Bitcoin or Ethereum or Solana or Near, you would see the foundational principle is redundant execution. There are diffs and mods to it, but the basic thing is everybody executes all the transactions, and therefore you know that you're correct. And to the extent that there is things like sharding, you're just finding a random subset of the nodes to basically do redundant execution. So that principle for building unstoppable, verifiable agents is not going to cut it. Agree? Okay, we agree on that too. So you're not going to build unstoppable, verifiable computers, agents, by building redundant execution, because redundant execution is very, very expensive, right? People say, oh, there is no more 10x to be had in blockchain. Stoli from Solana says this. I'm like, where are you living, man? We're barely getting started, right? So we can't do the total throughput. Like we did this last year. The total throughput of all of crypto together is like 7 megabytes per second. This is nothing, right? So if you believe this is going to power, most of human coordination, we've not even gotten started. Okay, so we agree redundant execution is not going to cut it. Now we have our favorite approaches, and so we get started fighting.
let's mention some other people's favorite approaches.
Okay, let's
that are
go.
not ours first.
No.
So there's
And not them done
ZK.
together.
There's ZK, which is like you
ZK, yeah.
You execute once, and then you prove to everyone that
Prove
you
to
pull.
everybody using cryptography.
Yeah. And the problem is that's like 100 to 10,000 times slower than executing directly.
Yeah, this is weird because when people first hear it, that's like it can't be true. You have all these ZK rollups, but just to give a sense of why it's working okay for just that purpose. You look at a ZK rollup. If you take the entire Ethereum transactions for a whole year and you want to just run the execution, it'll probably take you like $50 to do it on Amazon, right? So that's how much computation exists on Ethereum per year. And if your overhead is 10,000x or 100,000x for proving, you're still only up to like $500,000 or $1 million per year, and it's kind of okay. So that's why but Ethereum just gas per year costs like $1 billion, right? So by doing ZK proving, you're still reducing relative to Ethereum, which is a horribly slow computer. But relative to Ethereum, you're still like saving 1,000x, which is what this is why ZK rollups became a thing. But if you want to run an agent, right, take a couple of H100s, right, per good agents, right? So I want to take a couple of H100s.
Well, if you're running a deep research for 5 minutes.
That's it. You burn through. How much is that?
I know. But
Yeah. We're talking about like for good agents running continuously like tens of thousands of dollars a year, just execution. If you added a 10,000x, 100,000x factor to it, you're talking about $1 billion per agent. Just forget it, man. It's not going to work. So ZK, knocked out.
Knocked out.
Okay. What else is there?
Well, there's fully homomorphic encryption.
Whoa. Right now, clocking one transaction per second on Ethereum transactions.
I think there's a paper it's an MPC approach, but you're effectively getting 1 token per 5 minutes from an LLM running inside like a FHE MPC.
Frontier models?
Like a 7D. So 1 token per 5 minutes. It's all good. So anyway, now that we agreed on that everything else sucks.
Yeah.
I think that effectively, for those who were at my presentation, trusted execution environments, specifically hardware elements inside modern hardware, are a very good alternative to this. They provide you with verification. They provide you with confidentiality, which is also very important with AI. It also gives you a very interesting property that only this computation was done on your data and no other computation was done, which like ZK actually doesn't give you, or FHE. And so this gives you a very good, I would say, balance. And although there's some known like side channel attacks where you can effectively, here and there get a bit of information about what's happening inside the secure enclave, because in cases of machine learning, you're actually pushing a lot of data through this. It's not very helpful. And there's a number of mitigations, including oblivious RAM, that are actually addressing known side channel attacks.
Okay.
Top that up.
Okay, so first thing, unstoppability, right? So I said blockchains are unstoppable and verifiable. How do you get a TEE, a trusted execution environment, to be verifiable? I have a box sitting at home, take a big hammer, then blast it out. Now what happens to the data? It's just stuck inside this box, or what?
Yeah, so one single box indeed just gives you verifiability and confidentiality. And so you do need a network of these nodes that will provide you a few other properties. So on top, we're layering in proof of response, which is a protocol effectively ensuring liveness of nodes. So if one of the nodes gets hammered down by its owner, which is very expensive operation, by the way, for a GPU-based computer, there's effectively a way to detect it cryptoeconomically, slash the owner, of this hardware and then redirect the computation to another node. And obviously, you want to have effectively asynchronous Lambda-like AWS Lambda-like execution, so you actually have state encrypted at rest on the network, and instantiations are kind of per execution of the agent.
Yeah, so the one problem with this approach is, imagine Illia's approach, he has a group of nodes, n TEs, and he has, each of them have the data, right? So, but they're all inside the encrypted entry.
There's decentralized storage where encrypted data is stored, and so they can download and decrypt it.
Yeah. So the issue is, what if you take down all the nodes? Okay. So why am I talking about taking down all the nodes? Imagine in a blockchain like Bitcoin, all the miners go down, right? And still anybody can come and
wait for 10,000 years to mine the next block?
No, just like the difficulty adjustment protocol kicks in, and everything will be fine.
How long? Where's the current hash power?
I'm not sure.
It's pretty long.
It is long, maybe. But the point is, the data is there outside the network. Having data in plain text means your system is completely recoverable. People can say, oh yeah, hash power went down, let's just fork this and start from here and continue. The trusted execution environment model locks data into like these TE nodes. So we're making these additional layers of assumptions. I think it's natural, because I think what Illia's approach is trying to do is to get much more properties than what existing blockchains get, but for AI, right? So you've simultaneously increased the amount of computation, which is going from just transaction is sending each other money for no good reason.
What do you mean? Meme coins.
To now like doing arbitrary computation and demanding privacy. And so like suddenly the only thing that you can do for all of these things together is put them into like a trusted box. But I think this beats the spirit of our space to say like, Intel is our savior, they're going to kind of like, or NVIDIA for the, and they're going to stamp these boxes and we believe them. And not only the people who build them, but also all these people who are going to run them, because there are these possible side channel attacks. So my first concern on unstoppability is you're backing out from the superpower of blockchain, which is really, really unstoppable. To you have a group of nodes, you have to make sure that all, a majority of them are correct. If not, you can get shut down. You have to make sure that the entry control for them, which is, how do you know it's a valid T? And how do you know they're actually decentralized? How do we know they're not the same guy running n nodes? This is a fundamental problem with all of the blockchains, right? So we say decentralized trust, or this is a decentralized blockchain. But the blockchain itself, as protocols, have no way to measure if something's decentralized or not. And so it puts more pressure on these fundamental problems. Okay, so that's about unstoppability. There is some relative amount of unstoppability, but not the same thing as a regular blockchain. And then you go into the next one, which is verifiability. I asked this question. So, we have a protocol called Eigenlayer, which runs on Ethereum. It's a smart contract written on Ethereum. And one thing we did is we write this protocol and then let it marinate over time. And we have, we had that when ETH was doing well. $20 billion of stake. Now maybe it's 10 billion, the price down. But you have this, tens of billions of dollars can be locked up in a contract, because smart contracts on blockchains are infinitely scalable. Not scalable as in, you can increase the amount of throughput, but you can increase the amount of economic value transacted, because the trust system underneath it doesn't make a lot of assumptions. Like if you do this thought experiment and say like, hey, I'm running a blockchain, nobody needs to validate, it's Illia's T, and I'm going to just trust that, I can bet that you wouldn't get $20 billion locked into that, because who knows what he's doing with it. He may open the thing, run a scanning tunneling microscope, and figure out the key and do some key extraction. So there is an economic cost to this, to actually attack like a TE box. And that is not very easily quantifiable and is not linearly scaling. So imagine there are 100 nodes, okay? 100 nodes, 100 TE nodes. Does your security increase linearly? You don't know. Actually, like, once you have an attack, you can attack all of them. So there are all these weird non-linearities. Whereas money is very linear, right? So if you had $100 million and 100 people put $100 million, you get $10 billion. You can't double count money. Like, that's the problems that blockchains solve. So I think there is like a kind of fundamental difference in the level of security that you can get with the TE-based approach and the economic scale that you can drive on top of it versus a smart contract, blockchain, fully verifiable approach.
So, few things. I agree that we added the confidentiality, which I think blockchain kind of forgot that it's a really important aspect.
I think it is a major failing of blockchains that this is not a thing. I think we're going to face this very soon with when transactions are in real world, right? You go get a coffee, you go get into an Uber, and then I can find your public key.
Yeah.
Then I'm
your
going to go like,
staking balance.
it's getting personal here, man. Yeah, exactly. And I think it's not a good thing. So having confidentiality.
How are you solving confidentiality?
Go to the FHE, right? One transaction per second. We'll get there. I think there is a bigger discussion to be had around privacy, which is, I think, a really, really fundamental problem. And I think people are very, I actually don't know how it's going to pan out, whether people are going to be more sensitive about their data when it comes to these AI agents, as opposed to how they have been with their social media accounts. So I think that's going to decide how much people value privacy. But I think it's really useful to consider confidentiality as a kind of first-class citizen. But it is coming at a trade-off of other properties. It's coming at a trade-off on unstoppability and verifiability.
Yeah, so I mean, unstoppability you can effectively layer on where you need it, right? So as I mentioned, right, like if we don't want to rely on a single node, single provider, right, we are able to overlay with the protocol. The interesting thing is because the TEs themselves inside following the protocol, right, they cannot not follow protocol, you can actually have decentralization requirements because the computer itself knows where it is. I mean, obviously you can like trick it with a lot of stuff and layers of VPN or whatever, but there's ways effectively to ensure that if you want decentralization as a property, which again, in most cases for the specific use cases of machine learning, you don't actually need that. But if you want to have an distributed network, for example, for latency requirements and energy requirements, you can actually layer this inside the TE nodes themselves, require them and or route traffic to the closest latency node. And I think that's to me, the way I think of this is decentralization to me is a solution, not a problem. Right? The problem is right now that there is lack of power to power these data centers that are now GPU enabled because everybody's trying to put them into the same place. Right? Like right now in Memphis, there's a smog in the city because of a 200,000 GPU cluster that Elon Musk built because they're effectively sucking out all the power. There's same thing happening in Texas where they're building out the Stargate project. So there's a real actual impact on the from these data centers, and so there's no actual need to build them all super centralized. You can decentralize them if you have this ability to actually trust that the computation running by somebody else is actually done correctly. The reason why they're building them right now in such a proximity is actually not the fact that you need this big of a cluster to train models, like it's a very only for a limited set of things, and like people are to figure out how to train across clusters. It's really because like they want to maintain that and kind of run all the computation in one place. So addressing that, again, if I'm a user in Philippines and I'm trying to run a model, right, the model should be probably sitting somewhere close to me, not going around the world to back and forth between me and streaming data. And then everything from sovereign AI to kind of data privacy laws around like specific countries. So like all of that is actually getting addressed with TE, and like it's a practical concern that the rest of the world actually cares about. And decentralization here really is just a solution, like it's a methodology, and kind of to achieve those goals.
Yeah, I think to fully contrast the approaches, I need to at least present what approach we have in mind. So let me do that. On Eigenlayer, what Eigenlayer does is provide a shared security substrate, a common group of nodes and stakers that can opt in and run arbitrary new services. We call these services AVS, Autonomous Verifiable Services. Autonomous, they run on their own, unstoppably. Verifiable, if something goes wrong, you can catch them and hold them to account and then revert the state. So that's the autonomy and verifiability part. So these AVSs span all through the spectrum. We started initially with, maybe you can build an oracle, maybe you can build a bridge, standard services that crypto used to worry about. And then as you start thinking about it, you see like pretty much any service like AI inference, AI data attribution, model benchmarking, running an agent. So if you think about running an agent, actually it's not just running verifiable inference. You want to run like a model orchestrator. You want to run outside tools. You want to have your own database. Each of these layers needs to be verifiable. And in Eigenlayer, you have all these services which are autonomous and verifiable, and you can mix and match them to actually get the properties that you want. So this is our framework for how we think we can get powerful, verifiable AI agents and and enable the verifiable AI economy. The place where it becomes more complex is when we want to add privacy. And I think there is a real trade-off in all of blockchains, right, between the grade of security that you can get versus privacy. And until we have not just FHE, I think we need another like mega primitive IO, right, which is indistinguishability obfuscation, before we can actually solve the type of problems that you just throw at a TE and get for free. So yes, so that is an important addition to the space to actually think about how do you actually build privacy. But to the extent that the systems need high economic trust, I think using more verifiable, more unstoppable systems like what we are building makes more sense. So to phrase this discussion, I would like to categorize the types of AI agents that one may actually want to use, and then we can discuss which approach may be better for each one of these. So I think of three categories of agents. Okay. Number one, personal agents, right? Agents that either serve a human or a company or something like that. And so when you think about personal agents, it's better, it's not clear you need that to be unstoppable because they're under your control. It's not clear you want them to be like high-grade verifiable because either you can run it at the client end or you would outsource it to somebody that you trust, like Amazon or something. Right, AWS or GCP or Siri or somebody else, right? So, and people are used to this model because they do this all the time. They trust banks, they trust other computers. And so, but there is an agent or a person for whom these agents are serving, so they can actually make their choice. That's number one. I think personal agents are the ones where privacy is the most concern because you're going to give personal data to it. So Okay, so then the other agent types, I think of the second category of agents as agents of the commons, right? Like, think of near protocol, right? It's whose agent is near protocol? Is it Illia's agent? No, it's all of us. It's for all of us. It's the commons. Think of the Eigenlayer protocol. It's not for me or you or anybody else. Specifically, it is for all of us, right? Things that belong to the commons. And in fact, we use this word smart contracts, right? And they're pretty dumb, right? They're pretty dumb. You can't do sophisticated things in it. You can only do very simple things in it. And so I think of smart contracts getting augmented with intelligence as a huge upgrade to crypto, right? It's going to change everything in crypto. Everything in how blockchains work are going to be changed when you have intelligence natively embedded into contracts, smart contracts, right? So that's a huge, so second category called agents of the commons. And then the third category is agents that are not totally sovereign, right? So these agents are not working for you or me or for the commons. They're working for themselves, right? So they're totally autonomous, sovereign. They're kind of like their own living thing, right? So they have their own money. They do their own things. We need to figure out how to coexist with these things. And so I think of these three categories. And the level of unstoppability and verifiability increases as you go to the more from personal to commons to sovereign. And the level of privacy requirement, actually, like if you think about agents of the commons, you don't really necessarily need privacy for the things. Imagine an AI adjudication, okay? So I'm using an AI to adjudicate some complex dispute. This is what smart contracts were meant to do, right? To arbitrate programmatic disputes, arbitrate disputes programmatically, but they can only do it in very simple binary situations today. You could have an AI court to actually run very sophisticated disputes, replacing, nominal jurisdictions for this purpose. And so if you want to think about things like that, it's actually not clear. You want privacy. You want very high-grade verifiability, as high as you could get to. And the last one is totally sovereign agents. And I think giving them privacy is an absolute unmitigated disaster. So these agents are going to go rogue. They're going to attack us. They're going to do all kinds of crazy things. So we need at least observability before we get controllability. And so my gradation is personal agents, you need privacy. You don't need that much instability and verifiability. And maybe TEs are the right approach for it. I think far better than sending it to AWS, right? So I think we can agree on that. And then the next one, the agents of the commons, I think it needs to be at the same grade as a smart contract, because they're just making smart contracts smarter. And then the last one is sovereign agents. I think it's very risky to give their privacy. They're going to go rogue.
So I would, first of all, personal, yes, or user-owned. Then you have community-owned,
Yeah.
which is, I would say, somewhere before commons, right? There's like a subset of people. And you do want the privacy on that subset of people, but you do also want a way to share between yourself, right? I mean, this can be a company, a community on whatever, Telegram or any other, subset of people in the universe. I agree that commons getting indeed less required for privacy, but even for this adjudication case, like, do you want, your beef with someone to be went public, and or you want it to be, adjudicated by AI somewhere and kind of resolved quietly, right? So there is also like always, gradations of privacy and that involved in those things. And with autonomous agents, I think it's a really interesting question of, that we want observability. The thing is, like, if it's a truly autonomous agent, it doesn't matter that if you even have an observability, you're not gonna,
do anything about it.
Be able to enact much unless there is some governance controls and like tools that you already have in place. Those kind of things.
One of my biggest qualms is I think we absolutely need it. I think, in fact, my thesis is in 1 year, some AI is going rogue, using blockchains, we talk in blockchains about things like geographic sanctions, right? And it's a big stress point at the base of blockchains. I think there is going to be like a huge rogue AGI episode. And then we have to categorize blockchains as AGI safe versus AGI unsafe. And I would say pretty much all blockchains today are AGI unsafe because agents can just. So the idea that you're giving unconditional property rights, which is what blockchains do, giving unconditional property rights for rogue agents seems like an extremely bad idea.
I mean, that's the current state, right? We have
that is absolutely the current state.
We have North Korea moving money through the blockchains right now.
That's right. So and people are not happy about it. And at least for a country, some people will defend it to their death. That, okay, these people need to be able to have financial access. Nobody will be on our side when these rogue AGI take up money on chain and then go do crazy things with people. So and then we'll just be on our own. Okay, I think so when you think about fragility, which is what like Bitcoin and many of the blockchain systems are built to resolve, is to make systems anti-fragile. And when you think about the fragility of like a fiat currency, is fragility against like a Federal Reserve. But now you have fragility for blockchains against rogue AGI. So I think we need to resolve this. So it is not an option. I think it is a requisite, and it's good that Erica is putting together this meeting for us to come, both fight and resolve what are the problems that we need to solve. And I think making blockchains AGI safe is going to be super, super critical.
I think Erica is saying it's time for us to go and do patch some work on some blockchains to fix rogue AGI agents. That's effectively our clue. I mean, thank you. I think we just started the battle. I think we'll continue it online and in other mediums. Thank you.